Hi everyone, welcome to another episode with Venkat Varma Chemistry. In this session, we can discuss S block elements, April session JEE 2023. Have a look for question. Given below two statements, one is labeled as assertion and other labeled as reason. Assertion: sodium is about 30 times abundant as potassium in the oceans. Reason: potassium is bigger in size than sodium. In the light of above statements, choose the correct answer from the options given below. Now, have a look for question. Generally, sodium is about 30 times abundant as potassium in the ocean. Sodium indeed about 30 times more abundant than potassium in seawater. Sodium is indeed about 30 times more abundant than potassium in seawater. This is because sodium is more soluble in water than potassium. What is the reason? The reason is sodium is more soluble in water than potassium and is therefore more readily dissolved from rocks and minerals into seawater. Generally, potassium is bigger than sodium in size. Potassium is bigger than sodium in size as atomic number of potassium is more than sodium and potassium. Potassium has one additional electron shell compared to sodium, which means that its atomic radius is larger. Above question, potassium is bigger than sodium. The size of atomic number of potassium is more than sodium. Potassium has additional electron shell. Potassium is 4s1, sodium is 3s1, outermost electronic configuration. Compared to sodium and potassium, potassium has additional electron shell compared to sodium, which means its atomic radius is larger. According to question, which is right? Both assertion and reason are true, but R is not correct explanation of E. Both assertion and reason is correct, but R is not correct explanation of the A. It is the option is going to be option 3. Have a look for next question. Lime reacts exothermally with water to give A, which has low solubility in water. Aqueous solution of A is often used for the test of CO2, a test in which insoluble B is formed. If B further reacted with CO2, then soluble compound is formed A. Lime react with exothermally with water to give A. So lime means it is a calcium oxide. Calcium oxide is the lime. React with water, limited water, it gives calcium hydroxide, CaOH3. The process is known as slaking of lime. It is a slaking of lime. And the product is slaking of lime. It is an exothermic process. Exothermic means during the process heat released. That is a exothermic process. Now calcium hydroxide, aqueous solution is known as lime water. Calcium hydroxide aqueous solution is known as lime water and used for the and used for the test of CO2. Test of CO2. For example, calcium hydroxide, CO2, it becomes calcium carbonate, CaCO3. Calcium hydroxide with CO2, it becomes CaCO3. Now CaCO3, calcium carbonate with excess of carbon dioxide and water, it gives calcium bicarbonate, CaHCO3 taken 2. CaCO3 plus excess of CO2 plus H2O, it gives calcium bicarbonate. The milkiness is due to the formation of calcium carbonate. The milkiness is due to formation of calcium carbonate and disappearance of milkiness due to formation of calcium bicarbonate. Milkiness is due to formation of calcium carbonate and disappearance of the milkiness due to formation of calcium carbonate. According to our question, our option is lime react with exothermally with water to give A, which has low solubility in water. Aqueous solution of A is often used for the test for CO2. Yes. Which insoluble in B? If B further reacted with CO2, then soluble compound A. A is the slaked lime. A is the slaked lime. Slaked lime. It is the option going to be 2. Option going to be 2. Have a look for next question. In the following reaction, the total number of oxygen atoms X and Y. Na2O plus H2O, it gives 2X. Cl2O7 plus H2O, 2Y. Let's first balance the two given chemical equations. Na2O. Let's first balance the two given chemical equations. Na2O plus H2O, it gives 2 NaOH. It's going to be X. In this equation, there are 2 NaOH molecule. So the total number of oxygen atoms in the product, the total number of oxygen atoms equal to 1. Coming to next equation, Cl2O7 plus H2O, it gives 2 HClO4. It's going to be Y. HClO4. In this equation, there are 2 HClO4 molecule. So the total number of oxygen atoms present, the total number of oxygen atoms equal to 4. In this equation, there are 2 HClO4 molecule. So the total number of oxygen atoms is equal to 4. X has 1 oxygen, Y has 4. So in this equation, there are 2 HClO4 molecule. Total number of oxygen atoms equal to 4 oxygen atoms. X has, Y has 4, X has 1 oxygen atom. 1 oxygen atom. y has 4, x has y has 4, x has 1. It's going to be 5. 4 plus 1, 5. Coming to next question. Number of water molecules in washing soda and soda ash respectively. Number of water molecules in washing soda and soda ash. The chemical formula of washing soda is Na2CO3. Na2CO3 is a washing soda. Na2CO3 10H2O, which means each molecule of washing soda contain 10 water molecule. The chemical formula of washing soda is Na2CO3 10H2O, which means that each molecule of washing soda contain 10 water molecule. The chemical formula of soda ash, its formula Na2CO3. Na2CO3, which does not contain any water molecule, no water molecule. Therefore, there are 10 water molecule in washing soda and 0 water molecule in soda ash. Washing soda has 10 water molecule, soda ash has no water molecule. So let's check our option. Option is 10 water molecule and 0 soda ash. It is the option going to be third. Coming to next question. It is a massa following. List 1 is given and list 2. List 1 potassium chloride, potassium hydroxide, lithium. List 2 thermonuclear reaction, fertilizers, sodium pump, absorbent of CO2. So first of all, potassium. Coming to potassium, the movement of potassium ions is indeed involve the functions of sodium potassium pump. Potassium, sodium, potassium pump. Coming to potassium chloride. Potassium chloride is commonly used as fertilizers. In agriculture due to high potassium content. Coming to potassium hydroxide, KOH. Potassium hydroxide can act as absorbent of carbon dioxide. This property is primarily due to the alkaline nature of potassium hydroxide. So the KOH act as absorbent of CO2. This property is primarily due to the alkaline nature of potassium hydroxide. It means absorbent of carbon dioxide. Coming to lithium. Lithium can indeed participate the thermonuclear reaction, especially certain fusion reactions. So the lithium is participate thermonuclear reactions. So according to our question, the option should be 1. A is the 3, A coming to 3, B coming to 2, and C come to 4, and D come to thermonuclear reaction. This is our option 1. Coming to next question. Alkali metals from the following with least melting point: cesium, rubidium, sodium, potassium. Alkali metals, from moving to down the group means sodium, potassium, rubidium, cesium. From down the group, alkali metals, its melting point will be decreases. Melting point will be decreases. As move from down the group, alkali metal group, its melting point will be decreases due to increasing the atomic size. Due to increasing the atomic size. So this increasing the atomic size leads to decreasing the strength of metallic bond. So increasing the size means it's decreasing the metallic bond strength between alkali metals of atoms. The weaker metallic bonding resulting lower melting point. The weaker metallic bonding, this is leads to low melting points because less energy to require to overcome these weaker bonds to convert the solid metal into liquid state. It means, for example, sodium, its melting point will be 371 Kelvin, its melting point. Potassium, it is nearly 336 Kelvin, and rubidium, its value should be 312 Kelvin, and cesium, its will be 302 Kelvin. According to our question, which is a right option, right 1B, cesium has least melting point. Cesium will be least. This option 1. Melting point related to atomic size. So top to bottom atomic size increases. This is leads to decreasing the strength of metallic bonds of alkali metals. The weaker metallic bond, lower melting point because less energy needed to require to overcome these weaker bonds and convert the solid metal into liquid state. So cesium has least melting point in alkali metal. Coming to next question. MgNO3 taken to XH2O and BaNO3 taken to YH2O represent the formula of the crystalline forms of nitrated salt. Sum of X and Y equal to. Magnesium nitrate crystallizes with 6 molecules of water. Magnesium nitrate. Crystallizes with 6 molecules of water, whereas barium nitrate is anhydrous salts. Salt. The hydrated form of magnesium nitrate is MgNO3 to 6H2O. And anhydrous salt of barium nitrate BaNO3 taken to. So now X equal to 6, Y equal to 0. Y equal to 0 because there is no water. Anhydrous means there is no water molecule. Now X equal to 6, Y equal to 0. Now our answer is 6. Answer is 6. MgNO3 taken to 6H2O and BaNO3 taken to. There is no water molecule because X equal to 6, Y equal to 0.